In this problem, we have three logarithms, and we have to solve for x. So we have log base 2 of x minus 5 plus log base 2 of x minus 3 minus log base 2 of x, and that's equal to 3. So whenever you have two or more logs, in this case 3, you want to combine all of these logs into one so you can exponentiate. So first we'll use the product rule, right? Because there's a plus sign here. So that means that these two are going to turn into one thing, right? So this is going to become log base 2 of, and it'll be x minus 5 times, and then x minus 3. Okay, and then we have this last piece over here, minus log base 2 of x equals 3. It should be an interesting problem. Looks pretty tough. Now we have a minus sign, and that's going to give us a fraction. So it'll be log base 2 of, so the top piece is x minus 5, x minus 3. It's all being divided by x, right? That's the quotient rule, right? So it's this divided by this, and that's equal to 3. Okay, once you get here, you have to get rid of the log. So whenever you have a single log, as before, you want to exponentiate. So the base here is 2, so we're going to use a 2 here. So 2, 2. These cancel, so you get x minus 5, x minus 3 over x, and then that's equal to 8. Okay? Now we can maybe multiply by x, clear the fractions. So we get x minus 5, x minus 3 equal to 8x. And this is the part where we have to actually distribute. So let's go ahead and carefully do that. So x times x is x squared. And then x times negative 3 is negative 3x. Negative 5 times x is negative 5x. And negative 5 times negative 3 is positive 15. All of this is equal to 8x. I guess we can combine like terms. This is x squared minus 8x plus 15 equals 8x. Now we can subtract 8x minus 8x minus 8x. Long problem. X squared minus 16x, right? Because negative 8 and negative 8 is negative 16. Okay, so far so good. And that's equal to 0. All right, so this should factor. So if you get here and this does not factor, something is off, right? Because these problems are rigged. They're all rigged to factor, right? So let's see, we need two numbers that multiply to 15 and add to negative 16. Well, 3 and 5 won't work because 3 times 5 is 15. 1 and 15, yeah. 1 and 15, that works. And they're both negative. Yep, that'll work, right? Because then you get negative x in the middle and then negative 15x on the outside. That gives you the middle term. So the middle term is negative x, the outer term is negative 15, those add to negative 16. And then negative 1 times negative 15 is positive 15. Okay, so we get two possible answers, right? We get two possible answers. We get x equals 1 and 15. And unfortunately, we do have to check these. So whenever you have more than one log, you should always check your answers. So before we check, I'm going to rewrite the problem. So I have it in front of me. So log base 2 of x minus 5. You have to plug it back into the original too. You can't just like use another part of the problem. It has to be the original. Okay. All right. So we're going to check 1. Let's check 1. That's the first one we'll check. I use a different color. So everywhere there's an x, we're going to put a 1. Okay. So log base 2 of 1 minus 5. Plus, okay, already we're done right here. This is going to be log base 2 of negative 4. That cannot happen, right? You cannot plug in a negative number into a log. You can't take the log of a negative number. Because remember, the log function, it's got a vertical asymptote. It starts at 0, right? The domain is 0 to infinity, so you can't plug in negative numbers, and 1 minus 5 is negative 4, so fail. So right away, the 1 doesn't work. If you keep going here, and you use all the properties, it will check. But the thing is, this doesn't make sense. So you're not allowed to go from something that doesn't make sense to something that makes sense. So as soon as you see log of negative like this, game over. That's it. Throw it away. So 15 is probably the answer. I'm really tempted to just try it instead of checking, but let's check 15. Okay, so log base 2, putting a 15 there. So 15 minus 5 plus log base 2 of 15 minus 3. Yuck. Pretty nasty. I'm not a fan of checking. Log base 2 of 15 equals 3. Okay. 15 minus 5 is 10. So log base 2 of 10 plus log base 2. 15 minus 3 is 12 minus log base 2 of 15. And that's equal to 3. Okay, now here what we can do with these is we can multiply them, right? We have log base 2 of 10 plus log base 2 of 12. That's log base 2 of 10 times 12 is 120 minus log base 2 of 15, and that should be equal to 3. Wow, okay. Let's keep going. Pretty weird. Okay, let's keep going. So this is going to be log base 2 of 120 over 15, and that should be equal to 3. I'm not going to take any chances. I have the calculator here, I think. Yeah, it's still here. Good. 120 over 15. I mean, I'm sure we could probably work it out, but don't be a hero, right? Let's see. 8. Okay, good. I mean, we could have probably done that in our head, but not taking any chances. So log base 2 of 8 is equal to 3. Oh, yes, that works. 2 cubed is equal to 8, right? 2 cubed is equal to 8. So that does indeed check. Wow, what a lot of work. So the answer is 15. So we could have just taken a chance, put in 15, hit check answer, and skipped all this, but I wanted to just make sure. Sometimes it is no solution. Like if this wouldn't have worked, the answer would have been no solution. So that can happen. Is it going to happen? Probably not. Usually one of them works and one of them doesn't work. That's usually what happens in these problems. I hope that made sense.